Guys and girls, welcome back to the channel. This video is going to be on an RX-8 which we'd recently completed, and the owner has decided they want a bit more power and some rotary characteristics into the car. It's an RX-8 and it was one that we had done and complied, engineered, etc. Used it for a base to get the basics and the groundwork that is required to have it legal in New South Wales to be on the road, all certified, pass emissions, and all the compliance, etc. So anyway, Brad's the owner of the car, and he wants to bring some of that back into his car. So this is what we're going to do. He lives down in Canberra, so he's like 2.5 to 3 hours drive from here. It is his daily, and he's put plenty of Ks on it, and it does get used. So I thought it'd be a good idea to do a video, and we can sort of show and have a look at what kind of wear and tear is in the engine after the time he's put on it, and also to show people what's involved in going from something which is, I'll say near stock, but very mild porting to something more substantial, which will give it the idle characteristics that the Rotor is known for and that any rotor head wants. How we go about it, we want to semi-PP the engine, so we'll show you all that, and then to finish it off, we'll actually dyno it, and in depth we'll try and give you guys a good indication on what gains are made, not just on the pump 98 fuel, but just switching over to E85, what kind of gains we get, and overall what gain in power and any pros or cons to the characteristics of driving the car once the porting is done. When you do port a late model engine with drive-by-wire, you have the ability to manipulate throttle and smoothen out the whole idle experience. It's not like an old Weber fed or IDA style injection where a ported engine was just really ugly to drive at a low speed, low RPM scenario. So we'll show all that in detail. So strap in. This one's going to be a long video. If you like what you see, drop a comment, hit that like button, don't forget to subscribe, hit the hype button, share it with friends. We'll go downstairs and we'll start ripping this engine out, and we'll get this video started. Okay, so this is the engine out of Brad's RX-8. Like I mentioned previously, it was purely ported to get through emissions, to get engineering complied. The idea of the small tic-tac for the bridge was so that we could open up the secondary butterflies on the on the upper intake manifold, which would then allow the air to come through and give him some kind of, brap on the idle. However, it did do that, but it was not very pronounced at all. It was it just wasn't that rotary idle that everybody wants. So engines out and apart. This is what we are starting with. Engine's got roughly, I don't know, 10 or 11,000 Ks on it now. Pulled it apart, just put it in the hot wash to give the quick rinse. Everything looks immaculate, so this is what we are starting with, and this is where we'll go. So we're not going to do a whole lot in the lower. I'm not going to touch the secondary port in the lower, really just squared that up from the original port. These from an original port, the primary, haven't touched anywhere in the top closing edge of either port. That's standard. However, this one has come out. If you're familiar with an FD port, they're not quite big, however they are quite short in the width across here. So what we'll do is we'll cut a bridge in the primaries as well. We'll extend the closing time on the port. Literally just in the bottom here, I'm just going to blend that down so it's sort of level with the entry to the port. And on the secondary, the bridge will be cut a lot further. will raise the closing time of the port, and the housings will get semi-PP'd. So yeah, this is the before, and we'll get this done and show you what we end up with. Okay, so there you can see the before and after. So we haven't done anything in the opening of the port in the lower portion, but we've taken a bit up the top and we've extended the bridge, so that'll give us overlap in the engine, and it'll give it that notable rotary rub, which is what he wants. Okay, so they're all ported now. He's got a bridge port on all 4 ports. I'll put the housings up in the mill now and do the semi-PP on them. These plates, they'll go back into the hot wash. They'll spend probably 2 hours in there just to make sure it gets any filings, any dirt, debris. Obviously when you're porting, you're going to get a lot of shavings. You know, it'll fall down and make its way into here and into oil galleries. So pull all these out now, give it a good wash, and they're essentially done. I ran a stone over them quickly just to check for any marks. Got the usual signs of on the ignition side where it wants to try and kick the rotor. It puts the corner seal into this area here. You hear people often call it step wear, and it won't matter what happens. As soon as you run an engine, you will get a defined mark there. That doesn't catch your nail. I wouldn't even bother putting a dial indicator across that. But I reckon it'd be probably 1/4 of a thou at the most. It's more just a shiny mark where the corner seal's been running. Alright, so those will go back in the wash, and we'll get started on the rotor housings. Okay, so before we spend a couple hours in the mill banging some holes in here for the semi-PP, we want to make sure the housings are usable, in good condition. These ones look good. I can see the lightest bit of scuffing up around the trailing plug on both of them. That doesn't catch on it, but I can definitely feel a difference in the surface texture. The other thing you'll notice on these, I've got a little bit of calcium buildup in the water galleries, which is pretty normal. This one had distilled water and coolant, so it's quite good. One thing I've noticed is carbon buildup. We've got quite a good layer of carbon buildup in that exhaust port, and you can see where the rotor has actually dragged carbon up here, which has probably been on the apex seal, and I dare say just here is where a bit of carbon has been between the rotor and the housing and left a little impression. Being at the exhaust port, not overly concerning. It'd be better if it wasn't there at all, but it is. The rest of the housings appear really good. The other thing to check is, I'll go around and check that all the water seal grooves, I've got a prominent line where I can see where the actual O-ring has sealed up, and I've got an area right there. Now that black, brown, whatever you want to call it, is actually carbon. Another place where I can see it is on the spark plug side here. Now the exhaust port obviously gets quite hot, however peak cylinder pressure and temperature occurs here, and when I follow that line around, I can see that there's actually probably a minute bit of compression getting into there. So what I'll need to do first is run the stone over these, make sure they're flat. Also go back and have a look at the plates and make sure that the plate has a defined flat edge, which I have already checked, and it is flat. So whether there's a slight bit of shrinkage there, I'll have to check and make sure that they are within spec. And this isn't going to pose a problem further on. On the opposite side of the housing, you can see that there's a definite line where the O-ring has stopped. Water is obviously getting into this point here, but nothing's coming past the O-ring. Checking that as well. That's carbon. Again, a lot of carbon in the exhaust. Probably cut down on the premix on this engine. This side looks good. Yeah, so I'll run a stone over these, and then we'll get the micrometer out and we'll check these in those areas as well as here and here, and make sure we haven't got a problem with shrinkage in the rotor housing. Okay, so after miking these up, there's good and bad. In one particular spot, it's oversized. If you have a look where I did run the stone over it, you can see it completely took the witness mark where the water seal groove was. Now that's 80.05 up here. However, down here, where I suspect there's an issue, it's 79.98. Now these could be machined or lapped to get them back to flat. However, 79.98, that is undersized. You can machine the rotor to fit the housing, but it comes down to, or in my opinion, comes down to risk versus reward. Whilst I could machine or lap these down, get them 100% flat, I could put the rotor up in the surface grinder and take some off that. It's beneficial wise, yeah, it might save a couple of dollars or waste a couple of hours being a customer's engine. If it doesn't work out and there is an issue, I've got to warrant it. I've got to pull the motor back out. Anyone who's worked on an RX-8 knows how far back and down low the engines are. To get out is not the simplest of tasks. As you get older, things hurt more, like your back. So I think what I'm going to do is I won't use these housings. I'll put a new set in there and we'll start fresh. That being said, these housings are not junk. I'm not going to trash them. I'm not going to tell the customer that they're junk. They're just not fit for a boosted application. In a naturally aspirated engine, these would be fine. The cylinder pressure here is going to be a lot lower, not having boost into it. This engine was running, I think we had it up at like 26 or 27 pounds of boost to make a bit over 600. So a naturally aspirated engine, cylinder pressure being a lot lower, it's not going to want to try and push that combustion out under the O-ring. So yeah, these ones will go back in the washer and get a clean up. I'll talk to the customer. We'll more than likely trade these in and we'll put a new set in, and I'll get them up and start the machine work. Okay, new set of housings. I've just done the exhaust ports in them. Next thing we'll do on this engine is I'll pop it up in the mill and I'll take the spark plug bosses off. That way we don't need a machine down spark plug socket to get in there and get a plug if you're not using like a BUR style plug. If you're running the standard BR9 or a BR10, the hex is quite close to the surface of the plug there, so with that there you can't get your spark plug socket in. So I'll pop these up, machine them, then we'll flip them over and we'll run us straight through there, and we'll put a semi-PP port into here. So I'll get these up and get these underway. Alright, so housing's up in the mill. Pretty simple fixture that we come up with. The vise is obviously clocked up so that it's true and straight. We've got a machining angle plate which we know is 100% 90 degrees, and we just bolt the housing up to the angle plate so that I know that this is all going to be parallel. And we do exactly the same thing when we do the semi-PP or a full PP. Make sure that we're 90 degrees to the base, only difference being how high up we come with the port. These are literally just a bit of tissue paper, and that just, even though the vise is a smooth jaw, it just stops it damaging the side in any way, shape or form. It isn't super tight, it's just enough to clamp it in position so that the bolts going through the angle plate have no stress on them with it chattering and carrying on, etc. when I cut it. So we'll machine these plug bosses off. And that's it. Small counter bore, just get a little bit more exposure of the hex on the plug. The burr here will just take off by hand, there's no point moving it off center and taking the rest off. It's literally just a bit of flashing that's left over from the casting, and they'll break off quite easily. So we'll get the next one up and it'll be done. Okay, so first housing's up and pretty much done. Bored the 70 pp. This one will run a 25mm. I've cut the thread in the housing, and now the insert can screw in. Now that's upside down, obviously I need to turn it around the other way. Groove on the top, it's for an O-ring, which will then seat down in the bottom there. And I only need thread in the top because that's quite a tight fit. I'll probably put a little bit of heat to the housing, that'll drop down, and then I'll be able to screw that in and seat that O-ring, and then that thread there is literally just so I can put a bolt in there to wind it in. Once it's in and seated, I'll bore through the final cleanup size, which will be 25mm, which will match the hole in the bottom. So that's one down. I'll get the next one up, get that one done, and we'll put these inserts in and finish bore them, and the engine should be right to go back together. Okay, so insert's all done now, got an O-ring groove cut in it, and that's threaded in, sealed up into an O-ring in this space here. So this can come out now, that's the last one. We'll put some epoxy in this area here just as a safeguard, but that's essentially done, and we can start getting this engine together. Okay, so first housing's up and pretty much done. Bored the 70 pp. This one will run a 25mm. I've cut the thread in the housing, and now the insert can screw in. Now that's upside down, obviously I need to turn it around the other way. Groove on the top, it's for an O-ring, which will then seat down in the bottom there. And I only need thread in the top because that's quite a tight fit. I'll probably put a little bit of heat to the housing, that'll drop down, and then I'll be able to screw that in and seat that O-ring, and then that thread there is literally just so I can put a bolt in there to wind it in. Once it's in and seated, I'll bore through the final cleanup size, which will be 25mm, which will match the hole in the bottom. So that's one down. I'll get the next one up, get that one done, and we'll put these inserts in and finish bore them, and the engine should be right to go back together. Okay, looking at the rotors out of the RX-8 engine, everything looks fine. Oil rings still look brand new. We've got no signs of, a little bit there, but really no signs of combustion coming down in under the side seal, which is good. So we know it's sealing up well. Bearing wise, they still look brand new, so they're good. Make sure we've got all the springs are still springing on the corner seals, so they're good. Looking at the other one, first thing I notice is I've got some blow by in this area, and that corner seal is flat, and so is that, and that one's got bugger all spring in it. Alright, so we've got 3 flattened corner seal springs.
It has still been sealing up reasonably well, whether it's had a small lean out. I'll have to have a bit of a look at that. Oil rings still look good. Bearings are like new, so they're all good signs. So I'll go through that, find out, those springs are definitely flattened, so they'll need replacing. These side seal springs still seem good. So yeah, I guess other than a water retention kit, I'll flip this one over and make sure we haven't got the same issue on the other side. But other than a water retention kit, it's probably just going to get a couple of springs in the corner seals, and I think it can go back together. Okay, flipping the rotor over. Looks very good on the rear rotor. You see we haven't got combustion leaking in past the side seal. We've still got plenty of spring on the corner seals and side seals. Oil's reasonably clean still. Not to say that it won't get an oil change when it goes back together, but it goes to show that it's not burning up its oil. Front rotor, however, got some flattened, not a lot of tension on those corner seal springs at all, so we definitely have had an issue in the front rotor. Now, I'll check the gears. Normally, if it's a timing issue, we'll have some big marks on the bearings on the thrust side, and these bearings, I mean, that's the thrust side there. I've also got evidence of some rubbing on it, which every bearing's going to. It doesn't appear to show any signs of having too much timing and trying to push the crank out the intake side of the engine. So the bearings look good. The bearings are, I mean, they still look new. They're good. So I'll investigate this one further. That was the front rotor. I will check injectors. Make sure we don't have any discrepancy in the injectors. Make sure they're all flowing all right. We did have a turbo failure on this engine not too long ago, and it was leaking oil into the compressor. So, I mean, oil would, if the oil was going into the front rotor, I mean, the rotors have got carbon on them, but I would say they look pretty even. Oil will cause detonation if it was over premixed or if oil was being sucked into the engine. Oil doesn't have the same flash point as the fuel. Now this engine was running on pump fuel, and I think we had run some E85 in it just briefly on the dyno when tuning. Yeah, they all look good. So yeah, that will need a little bit of investigation. I'll probably end up putting some corner seal springs through the whole motor. Side seals all seem fine. I'll also check the apex seals and make sure they're all good as well. Looking at the apex seals, hopefully you can see it on camera, there is a distinct discrepancy in the wear pattern. You'll notice these top three, they're all quite uniform. Oh, that's got more, that's got more. They're all quite uniform in the heat. You can see where the heat's been in the end of the seal. However, if you look at the wear pattern on three of the seals, which were out of the front rotor, they at some point look like they've been unhappy. And if I look at that one there, that one's got some bend on it. That one, no. So one of these seals has been unhappy at some point, whether it was heat. Doesn't look like it's caught on anything. Yeah, so it hasn't jammed up or anything. It's just, that's a good sign that the engine at some point in time was not happy. So those three look good. Those ones you can just, like I said, you can see that wear pattern. and they were the front rotor. So they'll go out, they'll go in, and some corner seal springs and a water retention kit, and I think this engine's right to go back together. Okay, just a quick visual on flattened corner seal springs. There's 3 that I've just pulled out of that front rotor. Now if I compare them to a new one, you can see there's quite a difference there. So these are basically, that's the side that had tiniest bit of tension on it, so they're gone in the bin. And as far as a parts list, that's what we'll put into it. I have 3 apex seals, 12 corner seal springs, 6 outers, 6 inners, 1 apex springs, and we're good to go. Alright, so like we finished the semi-PPs. So these were new rotor housings. Thankfully, we do spend the extra time and check that the original housings that were in the engine had shrunk just under the spark plug here. It's a day's work to put that hole in it, and for it to be a complete waste due to a housing which is out of spec is less than ideal. So here's our first housing up. Second rotor housing going up. You can see nothing crazy on the exhaust. Make it streetable, no sharp edges, lots of radiuses, or should I say a continuous big radius all the way around. We do a notch in the housing just so it flows into the bridge a little bit nicer. It's not obstructed in its flow, it all sort of lines up there. Okay, the short block's now together. We'll cut, actually got another manifold, a semi-PP intake. I've got to put O-rings in here. We'll put some plugs in here where the original oil injection went. Engine runs on premix, so they get blanked off. Fuel rails and injectors are all right to go back in. Okay, so Brad's engine is all wrapped up. That'll go downstairs now, and I'll try and put that in the car tomorrow and get it fired up. He dropped it off last Saturday, today's Friday, so roughly a week. Pull that down, do the porting, do the machine work on the housings. I've got the semi-PP and I had to stud them as well. So that's all done. If I can get a couple of Ks on it over the weekend and early next week, and then get that on the dyno, and we'll show you what the difference is from before and after. I think last time on about 15 pounds, it might have been around a 420, 425 on pump fuel. So we'll see what the Bridgeport and the semi-PP does. I have no doubt we'll probably see a minimum of 50 horsepower gain. Some people that aren't sort of too familiar with the rotaries will be wondering why you go to the expense and the work involved to just port the engine. Obviously, it's the first thing is he wanted the noise, he wanted the brap. However, that does have some offset effects. Number one being that it'll make more noise, it'll also use more fuel, and the end result of that is it makes more power. So it's never a bad thing. So yeah, I'll get this downstairs now, and tomorrow we'll put that in the car and fire it up. Okay, engine's back in the RX-8. Coolant is in, oil's in. It's time to see if it starts. I might turn these fans off. It's a bit out. So yeah, finish the smoke test, make sure there's no leaks. Coolant's topped up, it's got oil, and everything looks like, I'm pretty sure I've got it all covered. I'll crank this over and see if she runs. Alright, so I've got oil pressure up. Now it is time to fire up. I'll turn this camera around and cross our fingers and hope for the best. Appears to be good. There's no leaks. We'll definitely have to bleed that cooling system, but everything looking alright at the moment. Plenty of oil pressure. Everything's going great. Perfect. Then life kicks you in the dick. It looks like the heater hose is pinched. And it's just piss coolant everywhere. And of course it's the bottom hose, the one that's barely long enough to even get on there to start with. That just became a Monday problem. Alright, so it looks like the lower heater hose on the RX-8 has been pinched and he's got a leak, so I'll let everything cool down. But the engine is back in, it's fired up. Should be a pretty straightforward fix. On Monday I'll probably just I'll get a bit of silicone hose and make a new one, a little bit extra length, as they're quite short from factory and they barely fit as it is. So yeah, we'll rectify that and fire it back up on Monday and see if we can't have it on the dyno by Tuesday or Wednesday. Alright, so I've got Brad's RX-8 back bolted up on the dyno. So we'd pulled the engine out and bridge ported it and done a semi-PP, and we had it back in the car, what was that, Saturday or something. So I've driven it to and from work for the last 3 days, so we've got 50 odd Ks on it now. It didn't get bearings or anything like that. It got a couple apex seals and some springs. That's pretty much all it really needed. All bearings that were good, so it doesn't really require a lot of bedding in. But yeah, we'll get it all sorted and see what it makes. was at this very moment the clutch said, "Fuck you." Okay, so we finished up on Brad's RX-8, finished on the E85 tune, targeting 30 pounds up top. We've done a couple of maps for the flex fuel, just to see where we're at as far as boost, and we've set the closed loop boost targets according to the ethanol content. So I'll turn this around, I'll show you where we got to. So from some previous runs, so prior to the engine being ported, these are all sort of out. I think we had a peak of, I think it was 18 pounds of boost, and that got us 426 horsepower. The power curve on the unported engine is a lot, it rolls over quite quickly. It doesn't rev out as much. where we come back to here on petrol on 98 on 15 pounds. We're up at 480 horsepower. So we've picked up around, what's that, 426 to 480. We've got about 54 horsepower gain there. Where we really start to take off is when we come over to here and we start putting boost into it. The turbo starts to come into its efficiency. But if we have a look here, this is going to be the big bum dyno. This is where it's really going to read. Holding the power all the way out here, where previous, we'd get to about 8,000. Prior to porting the engine, we get to about 8,000 and the engine was done. It is still rev, but it was going downhill. Where now we're holding it out all the way out to a 9400. And I mean, had we have gone further, it probably would have gone out past 10,000. But at the end of the day, it is a street car, and we're not trying to kill it. Even though we got over 100 pulls on the dyno now, just in the last 3 days. So we ended up with a peak 30 pounds. We can see here the clutch just wouldn't take it. We had 26.5 pounds here, and we had a clutch slip. So we let the car cool right down and had another crack at it. It held up to here. It made like 613 on 30 pounds of boost, but you can see it won't hold, so it's nosed over. Yeah, fuel wise, quite safe on pump and on the 85. Because he is going to go and do some track days, it's not like it just needs to make a quarter-mile run. So all the air fuel targets are in that low 11 to high 10 range. I think that'll be more than safe, and to keep it 100% safe, timing-wise, we haven't got a lot of timing in it at all. So just having a quick look, even on sort of 22 pounds of boost, we've only got 14 degrees of timing in it. And then when we're getting up to that 26 and then trying 28, we've got 10 degrees of timing in it on E85. Main reason being, this engine needs to live, or I want it to live. I want the engine to be in there for a long period of time, and I'm sure he does as well. He did want the engine ported to get the idle, the brap, so to speak. And obviously everybody wants to make more power on the dyno and get the engine to hold the power out longer. I feel like that's what we've got here. We've had a pretty good power increase. Yeah, so I think he'll be more than happy. The seat of the pants dyno, like I said, the first thing he'll notice, even on the pump fuel, is it just carries the power out a whole lot longer. So having an extra 1400 RPM of usable power is going to make a huge difference on the road. Speaking of what it's going to be like on the road, next thing to do is, once this rain stops, we'll get it out on the road and we'll see what it does, see how it feels. I think it's going to be quite a transformation on the car. Alright, so we're just going to take Brad's RX-8 for a road test, now that we've finished on the dyno and done everything that we needed there, just to get a seat of the pants feel on the difference that it was, or difference that there is. We'll just take it around the block and we'll see how it goes.
fucking scary ride. Skating.
Alright, so there's a quick road test on Brad's RX-8. How do you describe it? It's the mannerisms are still quite good. You definitely notice that little bit of overlap, mainly at the slower speeds on diesel. It's good up until it gets to about 2500, and then no matter what you try to do to manipulate the throttle, it still just has that little buck and jerk. Nothing quite like an old Weber-fed Bridgeport. Still quite nice to drive. Power wise, it just, like it did on the dyno, it just revs out further, so it just pulls harder. But yeah, third and fourth gear, it'll, like, you just roll into it and stand on it. It's we're on E85 at the moment, so boost target's 26 pounds, and it'll just light the tyres up in third and fourth. So he's definitely going to have to keep his wits about him. It'll keep him on his toes. I think probably for the track stuff, he might want to do a lower blend of ethanol, maybe bring the boost back down to sort of 20. Might be a little bit more manageable, especially sort of higher RPM coming out of corners. I have no doubt, unless he gets some really sticky rubber, this thing's just going to light the tyres up in a heartbeat. So yeah, that's pretty much it. Looking at the before and after dyno, on pound for pound, I think we're up like 50 something horsepower. Going back over some previous ones that was on Pump 98, a previous dyno session where we'd done a E85 tune and we had put 24 pounds of boost into it. We're up substantially. Torque is a big increase. The clutch had slipped previously on the dyno, and we changed the actual clutch plate itself, went from a sprung to a solid, and that seemed to hold. Now that solid just won't hold. So yeah, torque is up. The RPM band is up, like 1400 RPM. So as far as drivability, it's a much faster car. Definitely get you into trouble a lot quicker. Close to pound for pound, we're around 80 horsepower up when we're on E85, and up at 24 to 26 pounds of boost. That's where it's sort of comparable. So yeah, I guess if you weigh up money spent, effort done, and the results, it'll be up to the individual to decide whether or not it was a worthwhile cause to do. Personally, put the money thing aside, it's a better car to drive. The power band's not as narrow. It's not any laggier or doesn't come on any later at the lower RPM. If anything, it matches it maybe a fraction better. But the real gain is in that torque. It just consistently pulls all the way to a red line now. So yeah, I think he'll be more than happy with that. Look forward to seeing his thoughts on it when he takes it for a rip and takes it to the track and see what he thinks down at Wakefield Park. Alright, so that'll be it for this video. Thanks for watching. Don't forget to like, share, subscribe. Leave a comment, let us know what you think of the whole exercise. Was it worthwhile or not? And anyone who's out there thinking about doing one of these REW swaps into a Series 1 or Series 2 RX-8, just hit us up. Matt, Mr. Enforcer at Gmail, and we've got packages for these, so anything from very basic right through to hang on and your ass will pucker up and keep you sucked into the seat. Alright, till next time.